Question number 5.225. A source of light moves with velocity v relative to receiver. Okay, and demonstrate that v is very much smaller than the speed of light. The fractional variation of the frequency of light is given by the equation, that is 0. Delta omega upon omega is equals to v over c into cos theta. Okay, where v is the velocity of source and theta is angle between source motion, direction and observer's line. Right. So this question is based on Doppler's effect and we have to prove this relation. Okay. So let's assume there is an observer. Okay. This is our observer which is stationary. And there is a source in same line. And this source is moving at certain angle with velocity v. Suppose this angle is theta. Right. Now, the velocity vector that will affect on received frequency would be along this line. Suppose this component is VR. And from vector resolution we know it that there will be two components of this velocity. And this VR component is equals to v cos theta. Right. Now suppose this source generates small pulses. Okay, let me write here. Let source generate small pulses at time interval t naught. Okay. So if it generates any pulse at time interval t naught, then before generation of second pulse, this pulse would cover a distance c into t naught with the speed of light. Right. In same time duration, this source will change its position and the relative position of source would be along the observer is Vr into t naught. Okay. So the effective wavelength observed by this observer would be lambda, which is actual distance covered by wave minus distance covered by source in the line of observer. Right. Because this much distance, relative distance will be observed by the observer. Right. Between source and observer. So from here we can calculate frequency received. Frequency received will be speed of light divided by wavelength received by the observer. So this is c divided by t naught into c can be taken out, that is 1 minus Vr over c. Right? C and c would get cancelled and 1 over t naught is frequency generated by source. Let this generated frequency is f naught. So we can write this is 1 over 1 minus Vr over c into f naught. Now we have to calculate the difference, that delta omega upon omega, or we can say delta f naught over f. Right. So if we'll calculate delta f naught over f, so we can write f, here source is moving towards the observer, so f minus f naught over f, what we want to calculate. Right. So from here we can substitute this expression, that f naught into 1 minus Vr upon c. Okay, this is f naught divided by Vr minus c minus f naught divided by f naught divided by 1 minus Vr upon c. Right. So from here we'll get delta f upon f naught is equals to Vr upon c. Right, from this calculation. Now Vr is component of the velocity along the line of observer, that is v cos theta. So from here we may write delta omega upon omega or delta f upon f, which is equals to v cos theta upon c.